Hello, this is Math 18, Section 3.1. Get my pen. Okay. Today we're going to be looking at factors and prime factorization. So we'll be looking at how to find all the factors of a number and how to prime factor numbers. So, when we're talking about factors, natural number factors of a number go into another or given number evenly. There's no remainder. So that's the definition of a factor, okay, is that they divide into a given number evenly. Now, if you think about the number 6, the factors of 6 are 1, 2, 3, and 6 because all of those numbers divide into 6 evenly, okay? So what we're going to do is look at how to find all the factors of a number. And what you do is you start and you divide by 1, by 2, by 3, by 4, by 5, etc. Okay? And any of the numbers that go into our number, the given number, evenly, those are your factors. And you want to keep dividing until you have a pair of factors that starts to repeat a pair that you've already written down. Okay? So I'll show you what we mean in just a sec. All right, so before we get into a problem with finding the factors, there's some divisibility rules that will help you so much in this section about finding factors or being able to prime factor numbers. So if you want to know if 2 goes into a number or not, 2 will divide evenly into all even numbers, okay? So in other words, if the last digit of the number is an even digit, 0, 2, 4, 6, or 8, 2 will go into that number, no matter what the number is, okay? Now, 3 is a cool divisibility rule, and a lot of people don't know this, but once you know this, it is such a helpful rule to use, especially in this section, is that if a number is divisible by 3, if you add up the digits, and the sum, if 3 goes into that sum, then 3 goes into the big number, okay? Now, so here's an example, 57. Most people don't think of 3 going into 57, but add the two digits together. 5 plus 7 is 12, and 3 goes into 12, so 3 goes into 57, okay? Same thing if you had something crazy like 2031. I would never think 3 going into that. But if we add up the digits, 2 plus 0 is 2, plus 3 is 5, plus 1 is 6. Well, so if you add up all those digits, and we got the 6 there, 3 goes into 6, so 3 also goes into 2031. So if you add up the digits of your number and 3 goes into that sum, then 3 will go into the number. Okay? And the last two divisibility rules, most people are pretty familiar with these. 5 will go into any number that ends in 0 or 5, and 10 will go into any number that ends in 0. So those rules are just good to know to help you with these factoring and prime factoring problems. All right, so number 1, we want to find all the factors of 42. So I write mine down in pairs because I think that's a little bit easier than trying to list them out in numerical order. So, because it just is easier to keep track of. So what you want to do is you want to, don't jump around. You want to start with 1. So 1 will go into 42 times. So I list 1 and 42. Okay? The next number I'm going to try is 2. Well, 2 goes into 42 21 times. So you write that down, okay? Now, if you're not sure, you do 42 divided by 2 on your calculator and it gives you 21, okay? Now, the next number we're going to try is 3. And most people think, oh, 3 doesn't go into 42. Well, first of all, if you think about the 3 divisibility rule that we just learned, 4 plus 2 is 6. So 3 goes into 42. If you're not sure how many times, use your calculator. And if you divide 42 by 3, you get 14. Nice and even. So 3 and 14. Okay? 4, you try the next number. 4 does not go into 42 evenly. Try 5. No. 6 will go into 42 evenly 7 times. Okay? Now, the next number is 7. Well, 7 goes 6 times. That's a repeat of the factors that we just wrote down. So, you can stop. As soon as you get a set of factors that repeats one that you've already written down, you're done. Okay? Now, if you want to be really fancy, when you put your numbers into probably the online WebAssign program, they will probably ask you to separate them by commas. So you could start at the top and go down that column and go back up the second one, and it puts it in numerical order for you. So I'm writing 1, 2, 3, 6, 7, 14, 21, and 42. But you could put them in any order you want to put them into an answer. The order doesn't matter as long as they're all in there. That's the important thing. In fact, I don't even write them in a list. I just leave them in pairs like that. It's only WebAssign that wants them in a list, but they do not have to be in numerical order. So make sure you realize that. That's no big deal. All right, number 2, find all the factors of 50. So once again, we start with 1. Well, 1 times 50. Okay, that works. 2 goes 2 times 25. The next number we choose or try is 3. 3 does not go into 50. 4 doesn't go. 5 goes 10 times. 5 times 10. 6 doesn't go. 7, nope. 8, nope. 9, nope. 10 times 5, that's a repeat of 5 and 10, so we're done. That's it. Okay? All right, here's the next one. Find all the factors of 30. So once again, start with 1. 1 times 30. 2 goes 15 times. Then we try 3. 3 times 10 is 30. 4 does not go into 30. 5 goes 6 times. And then the next number, 6 times 5, that's a repeat, so we're done. Okay? Number 4, this is one that a lot of people miss some of the factors because they don't go in order. So remember, once again, start with 1. 1 times 48. Okay? If you divide by 2, it goes 24 times, nice and even. And 3, a lot of people, I'll ask in class, does 3 go into 48? And everybody says no, and they don't even check it. 4 plus 8 is 12. 3 goes into 12, so 3 goes into 48. So if you're not sure, don't guess. Use your calculator. 48 divided by 3 gives you 16. Okay? 4 will go into 48 12 times. 5 does not go. 6 goes 8 times. 7 doesn't go. And 8 times 6 is a repeat of the last one. So we can stop. So that's what you want to do. You just keep dividing until a pair of your factors repeats. Okay? All right. So here's some for you to try. Pause the video and try these on your own. Number 1, find all the factors of 36. So start with 1. 1 times 36. 2 goes, 18 times if you divide that out. 3 goes 12 times. 4 times 9 gives me 36. 5 doesn't go. 6 goes 6 times. Now, see, here's kind of weird. Like if you're listing all of the factors of 36, you're not going to write 6 twice, okay? Because they just want all the factors. So I'll show you how to write it out in just a second. So now 6 goes 6 times. 7 doesn't go. 8, nope. 9 times 4, that's a repeat of a previous factor. So when you write out this list of factors, you're going to have 1, 2, 3, 4, 6. You only write 6 one time because that's the factor is 6. 12, 18, 36. So just make sure you don't write it twice when you're listing your factors. Now, if you wrote it in the columns like I did and say, for instance, you type that in and they marked you wrong, I can help you. I can fix that, okay? So don't worry about it. But you don't have to write it twice in the list. Okay, number 2. Find all the factors of 18. So once again, start with 1. 1 times 18. 2 times 9. That works. 3 times 6. 4 doesn't go. 5, nope. 6 times 3 is a repeat, so we stop. Okay? Number 3, find all the factors of 60. So 1 and 60. 2 times 30. 3 goes 20 times. Now 4, a lot of people miss this one. They think 4 doesn't go, but it does 15 times. Okay? 5 goes 12 times. 6 times 10, that works. 7, nope. 8, nope. 9, nope. But 10 times 6 is a repeat, so we're done. So there's quite a few factors of 60. Okay? All right, so now we're going to look at prime numbers and composite numbers, okay? And prime numbers are very helpful in a lot of different applications in math. For this class, we are mostly just going to be using them for finding the prime factorization of a number, but we will also use them later on in this chapter for the greatest common factor and the least common multiple. So we'll be using this whole idea of prime factorization 3 different times in this chapter. So a prime number is any number greater than 1 whose only 2 factors are 1 and the number itself. So say for instance 7, okay, that we've got here. 7 is prime because its only factors are 1 and 7, okay? All right, and if a number's not prime, then it's a composite number. That means it's composed of more than just those 2 factors. It has other factors. So 6 is composite because it has 2 and 3 as other factors of 6. Okay? So here's some of these are the prime numbers less than 50. There's a whole bunch more prime numbers than this, but this is just to show you an example of some of the ones that are less than 50. Prime numbers go on forever and ever. They just found the largest known one probably 10 years ago, something like that. But here are your prime numbers that you mostly need to remember. Mainly 2, 3, 5, and 7. Those are the main ones. You'll see 11 and 13 every once in a while, but 2, 3, 5, and 7, we'll be using those constantly in the rest of this section. Okay? Okay, so to prime factor a number is where you take a number and you break it down until the only factors that you're using to get back to that number are prime factors, okay? So you write it as a product of all of its prime factors, okay? And we're going to use factor trees to help us with this. And anytime you get down to a branch that ends in a prime number, you circle it, okay? And then all of the circled numbers multiplied together gives you back the number you started with. Okay, so each time that you're doing this, you can start and break it down into any 2 numbers that multiply to the given number, but you just keep working down until all of the numbers on the tree are prime numbers. Okay? All right, so look at this. It says find the prime factorization of 120. Now, that's a pretty big number. First of all, with me, with any number that ends in 0, I know 10 goes into it because 10 goes into every number that ends in 0. So I want to break this down into 10 times something that gives me 120. Well, if you're not sure what it is, take your calculator. 120 divided by 10 gives you 12. Okay? Now, you ask yourself, are 10 and 12, are those prime numbers? No, because there's other factors of 10 other than just 1 and 10. So remember the prime numbers that you're mostly going to be using, 2, 3, 5, and 7. Okay? So I can break 10 down into 2 times 5. Well, 2 is prime, so I circle it. 5 is prime, so I circle that. All right? 12 I can break down into 3 times 4. What if I had decided to break down 12 into 2 and 6? That also works. That's what's so crazy about this. As long as the numbers that you break it into go back and multiply to the number above, it's good to go because at the end it'll all come out the same. Okay, and I'll show you how that works. So 3 is prime, so I circle it. 4 can break down one more time into 2 and 2. Okay, so this is not your answer. The factor tree is not your answer. Your answer is where you write out the multiplication. So we have 2 times 5 times 3 times 2 times 2. You don't have to keep it in numerical order. Some people like to. They like to write it as 2 to the third using exponents times 5 times 3. However you want to do it, it doesn't matter. I don't know that WebAssign, they may want you to write out all the factors. They may not want you to use an exponent. You'll just have to see. Now, so let me go back. When we split it into 10 and 12, okay, 10 and 12. Well, 10 can only be broken down into 2 and 5, okay? But this time for 12, I'm going to use 2 and 6. Well, 2 is prime, right? So I circle it. 6 breaks down into 2 and 3. Those are both prime. So look at what I have. 1, 2, 3 2's. That's 2 to the third, 5, and a 3. So you get the same answer. It doesn't matter which way you break it down as long as your numbers multiply back to the number up above it. That's the whole idea. And you can check your answers, because if you multiply 2 times 5 times 3 times 2 times 2 and you don't get 120, you are barking up the wrong factor tree. So you need to make sure that those multiply back to 120. All right, look at the next problem. Find the prime factorization of 57. Okay, so I usually think about 2 first. Well, 2 won't go into that because that's an odd number. But now try 3. Remember, 5 plus 7 is 12. 3 goes into 12. So 3 will go into 57. And if you don't know how many times, use your calculator. I think it is, that's not right. 57 divided by 3. Yeah, oh, I guess it is 19. Okay? So 3 is definitely prime. 19 is also prime. So your prime factorization there is just 3 times 19. Okay? Okay, number 3, find the prime factorization of 198. So I'm going to start up here because it's a little bit bigger number to give myself more room. So since it's a big number but it's even, I'm going to start with 2 because I know that 2 goes into every even number. And let's see, if I divide that by 2, I get 99. So don't guess, use your calculators, okay, so that you make sure your factor tree is correct. Now, 2 is prime, so I circle it. 99, I can divide that by 9, and that would be times 11, okay, because 9 times 11 gives me 99. Now, 9 is not a prime number, but 11 is, so go ahead and circle the 11. But 9 I can break down into 3 times 3, and those are both prime, okay? So our answer here, you go back and pick the circled numbers, 2 times 3 times 3 times 11, and that's your prime factorization. All right? Okay, number 4, find the prime factorization of 153. So I think 3 goes into this. Let's see, 1 and 5 is 6, plus 3 is 9. 3 goes into 9, so 3 will go into this 51 times. Okay, so 3 is prime. Now look at 51. Add 5 plus 1. That's 6. So 3 will go into this. 3 goes into 51. I think it's 17 times. Yep. Okay. So 3 is prime, so I circle it. 17 is also prime. So now we're done because all of our branches end in a prime number. So the prime factorization is 3 times 3 times 17. All right, let's see what's next. Find the prime factorization of 70. So with 70, I'm just going to keep it simple. I'm just going to do 10 times 7. I mean, you know, if there's simple numbers that you can think of multiplication tables for, that's what I would go with because it's a little bit easier. 10 I can break down again into 2 times 5. Those are both prime, and the 7 is prime. So that's it. 2 times 5 times 7. Okay? And number 6, find the prime factorization of 616. That is a big number. So I'm going to start with 2 because I can't even think of anything else that would go into that because it's so big. Divided by 2 is 308. Okay, that, circle the 2. 308 is still a really big number, but it's even. So I'm going to divide by 2 again. Okay, so if we divide by 2, we get 154. Okay, that is still an even number. So you guessed it, I'm dividing by 2 again. Okay, when I divide by 2 there, I get 77. Now, I am using my calculator the whole time. Okay, I'm not guessing. I'm using my calculator to make sure I keep it straight. All right, 2 is prime. 77, now finally I can know something here without having to use a calculator. That's 7 times 11. Okay, I can break that down into that. 7 is prime, and so is 11. So finally, now we're done. So that tree only had one long branch off to the side. So we have 2 times 2 times 2 times 7 times 11. And that's your prime factorization there. All right, so here's some problems for you to try. Pause the video, try these on your own, no cheating, and then check yourself to see how you did. All right, number 1, the prime factorization of 126. So I'm going to start with 2 because that's a big number. The 126 is, 2's not. Okay, so when you divide by 2, you get 63. All right, 2 is prime. Now 63, I'm just thinking about multiplication tables. 7 times 9 gives me 63. I could have also divided that by 3. 3 and 21. Either way works. It doesn't matter. Okay? So 7 is prime, but I can break 9 down into 3 times 3. So I just always try and think of, if I can think of multiplication facts that work, that to me is easier. But any way that you break it down, as long as it multiplies to the number above, any way you do it is fine. Okay? So we have 2 times 7 times 3 times 3 there. All right? Now the prime factorization of 260. So that's a big number, but it's ending in 0. So I know that's 10 times 26. And that just, really splits it up nice and even there. Not even, but, pretty much smaller numbers. So 10 I can break down into 2 and 5. Those are both prime. So I circle those. 26, if I divide by 2, I get 13. 2 is prime, so is 13. So I have 2 times 5 times 2 times 13. And that's your prime factorization there. All right, number 3, find the prime factorization of 48. So here, I'm just going to use multiplication tables. 6 times 8. Okay, if you use 2 times 24, 4 times 12, 3 times 16, any of those are fine. Okay, it doesn't matter. But I just like to start with numbers that seem, easy to think about for multiplication. So 6 breaks down into 2 times 3. Those are both prime, so the 6 is done. 8 breaks into 2 and 4. 2 is prime, but now the 4 you have to keep going until you have prime numbers there, 2 and 2. So make sure if you do not have a prime number, you have got to keep going, okay? And if you need to write, those main prime numbers on your paper as you're going, 2, 3, 5, and 7, to keep you straight, that'll help. All right, so we have 2, 3, 2, 2, 2. Right? 1, 2, 3, 4 2's and a 3. Yep. All right, number 4, find the prime factorization of 350. So because it ends in 0, you can just think about that 0 being knocked off. 10 times 35. All right, so 10 is 2 times 5. We've done that quite a few times already. Those are both prime. And 35, 5 times 7. Well, 5 is prime, so is 7. So that one didn't take long at all. We've got 2 times 5 times 5 times 7 for that prime factorization. All right, number 5. Find the prime factorization of 102. So it's even, so I'm just going to start with 2. And that would go 51 times. So 2 is prime. Now, most people think 51, you're done. But remember, add 5 and 1, you get 6. So 3 goes into that, and it goes, 17 times. Okay? 3 is prime, and so is 17. So we have 2 times 3 times 17. And I think this is the last one. Number 6 is find the prime factorization of 72. So I'm just going to break it down into 8 and 9. Okay, 8 I can break down into 2 times 4. 2 is prime. 4 I need to break down into 2 and 2, and those are prime. And then 9 would be 3 times 3, and those are prime. Okay, so you're going to have 2, 2, 2, 3, and 3, and that would be your answer there. And I'm pretty sure that is it for section 3.1. Yep, that's it. Make sure you do the homework and quiz. Good luck.